I think you should.
All right, how's everyone doing?
Oh my God. Do you want to recess?
So I finished grading your SLPs, okay, the first pass of them. If you got 25, if I said no need for V2 or V3, you're good to go on your proposal. If you did not get a grade, then you've got some comments. Thanks. Then you've got some comments on there saying, you know, please add this or expand that or something like that. So please read your comments and respond accordingly. If you've already responded to that, I have not done a second pass through the SLPs yet. I'll get to that probably tomorrow. But first pass should be done. If you did not turn in your SLP proposal at all, you've got a 0 on there for the version 1. Go ahead and turn in the version 2 as soon as possible, right? Ideally before the deadline, so that we've got your proposal nailed down. All right, so I want to talk about ArgC and ArgV a little bit today. We talked about this in the A section yesterday, and I want to talk about it in here today. And then I want to talk more about Linux. I also want to talk about how to deal with the new line at the end of fgets. That's one thing we haven't dealt with yet. Any questions before we jump into all that? Has everybody had a chance to sign in? All right, so let's play with stuff. So let me start with fgets.
Too many words for me to read, and that's why I skipped it.
So real simple test code section here. So we've got a temporary character array. We'll prompt the user to say something. We'll read what they said with an fgets. I'm not bothering to check the return value. I'm not going to hit end of file on you. We're just going to read from standard in, save the input into temp, and then we're going to print out you said, and we'll print the value of temp like that. So there's one of those moments where exclamation asterisk came in handy, because I typed GC instead of GCC, and I didn't want to type the whole thing again, so I just said GCC exclamation asterisk. So let's go ahead and run this, and we'll say hello there. And it says, you said hello there, new line, didn't you? Right? And this is a pain because we don't want the new line in there. We wanted this to all come out in one line. So say something, hello. You said hello, didn't you? Okay. And that's not exactly what we want. So let's figure out how to clean this up. Our temp is a character array. And let's say I say hello. It's actually equal to hello new line. So if we look at this as a set of characters stored in an array, what do we have in memory? We have H, E, L, L, O, and then a new line, and what's stored in the next position? Null terminator, right? Character 0. Null terminator is just ASCII code 0. And so when we print out the value of temp, what does printf do? It starts printing until it finds a null terminator, and then it gives up. So it only prints that much of it. All right. What could we change in this version of temp if we wanted the null terminator if we wanted the new line to go away? If we didn't want to see the new line when we printed out temp?
You could just replace the new line with a null terminator.
Just replace the new line with a null terminator. And that does two things. One, it gets rid of the new line, right? And it ends the string at that point. So now our string is really just HELLO. That's the end of the string. It's down to 5 characters now. So let's do this. So I'll set temp bracket 5 equal to 0. And it's \0 in a single quote. That makes it a character, which is equal to the null terminator. So now if I say hello, it says you said hello, didn't you? And it's all on one line. Now that's not a big deal. That's not going to bring about world peace, but it helps, right? So it's
But you're only doing it
a
for
convenience.
the 5th one. Like if you say hello Nick.
But I'm only doing it for the 5th one. If I say hello Nick, it says you said hello, didn't you? If I say ha, it says you said ha, new line, didn't you? Right? So it's not a general solution yet. Why? Because it's not always temp bracket 5. Now suppose temp is ha with a new line. So this is H, this is A, this is new line, this is null terminator. What do I want to set equal to the null terminator in this case? 2. We'd get there eventually. Alright, set temp bracket 2 equal to 0. Okay, so we need a rule. In this case we wanted to do 5, in this case we wanted to do 2. What's a rule we can use?
If temp at such and such position equals /n, temp at such and such position equals /0.
Okay, perfect. So we could make a loop that goes through and checks each character, and if that character is equal to the new line, \n, then we set it equal to \0. So that works perfectly. Is there another way?
Oh, I have a general question about strings.
Okay.
So all this works in C, but do other languages have a similar way to deal with strings? Like, are all strings arrays of characters?
No, Java, most languages do not treat strings like that.
Oh.
C is kind of peculiar that way.
Okay.
But they did it first, so it's a cool way to do it.
Okay.
But like Java, for example, string is a native type, right? And strings come with a property called length. And you can just check string.length and it'll tell you how long the string is, and it's got nothing to do with a null terminator.
Do they have null terminators and stuff like that in there?
No.
But
Null is just another character.
Do they have new line?
They have new lines, yeah, that's a character.
Interesting.
And they have carriage returns and form feeds and all kinds of things.
we could just take the length of the string and then subtract 1, put that as the new line.
Yeah, so this is a potentially easier way. If we set temp equal to this, and we look at the length using string length, it's going to be equal to 6. HELLO, new line, that's 6 characters. How does it know? Because string length is a for loop that starts at the beginning and loops through until it finds the null terminator. However many times it looped, that's what the string length is. So if temp is ha with a new line, string length of temp is equal to 3. So if string length was 6, we want to zero out element 5. If string length was 3, we want to zero out element 2. Let's generalize. That's what makes humans successful in general. Let's just set string length of temp minus 1 equal to the null terminator. Now don't do something twice and say, I guess it always works, and then just do it, right? Think about it. Does this make sense, right? We've got this, yeah, go ahead.
So if arrays start at 0, right? So
Mhm.
wouldn't you have to do like -2
Yeah, so index 0 thing makes things funny, right? Index 0 means the first character is at index 0, the second character is at index 2, the nth character is at index n minus 1. Okay? If string length is equal to 6, then the sixth character is the new line that we want to get rid of. That's the last character. So the sixth character is going to be at index 6 minus 1. So the new line should be at index, whatever the string length is, minus 1. And that's what we want to set to a 0. So I think minus 1 is correct. But depending on what the weather's like outside, sometimes it seems like minus 2, sometimes it seems like minus 0. So usually I do a couple of test cases, I decide what it is, then I'll think about it and see if that makes sense. And then you're probably good to go. And if we're not, we'll discover it because we're really good at doing lots of test cases. So string length of temp minus 1, let's set that equal to the null terminator. And I forgot to include string.h, because if you're going to use string length, you got to have string. So if I say hello, that works fine. If I say ha, that works fine. If I say a bunch of stuff, that works fine. So that's just a trick that comes up a lot. Anytime you're using fgets, more often than not, you end up seeing something that gets rid of that null terminator. And I pushed similar version of this code over to the server already. So you can just look for the latest file over there. I think it's called more fgets code or something. All right, questions about that? All right, we're going in deep now. So I want to look at argc and argv. Bless you.
Thank you.
Can I ask a question, but not about that?
Okay, cool.
What would happen if you put a function inside of main?
You put a function inside of main.
Because normally you don't have to write a function after main, right?
Right.
What would it do?
Well, the best way to find out.
Break the whole universe.
Well, because I don't know how.
You never know what's gonna like break the universe
Because no one's found out yet.
because no one's found out yet. So that seems to work. So let's try calling this function. There.
So it doesn't matter.
So
But that means you don't need to include a prototype.
don't need to include a prototype. Now that may be local to main, so it may be that if I had another function, it would not know about this. I don't know if
I
that's
think-
the case or
I
not.
think so. I think in C it is.
Yeah. I'm pretty sure this is not standard Kernighan and Ritchie C. It's probably, C99 or something that allowed this. But that's interesting. I wouldn't do it, but, because I don't know what the portability is, but that's cool. I never knew that you could do that. Cool.
Can we put another function in that function?
Probably, yeah. I'm pretty sure if it worked once, it'll work again.
But would that function that's inside fun be callable from main?
Probably, ooh, it's a good question. Nope.
Oh.
Yeah, so I think it's really like tightly scoped.
Can you
So you
call
can-
main?
Can you call main from main?
Or like from within function too?
Sure. So this will blow up my stack beautifully.
But it's
But
still.
I gotta get rid of that. This may be the last thing I do with my laptop, so we may be back on the whiteboard after this. Oh, it's arrived.
It didn't even run it twice.
Oh, I didn't actually
Yeah.
call fun 2.
Okay, so
So it's, oh, okay, we're saved because main wants some input in the beginning.
Yeah.
So it's not just going crazy. And now I can like, yeah. But if I didn't have that input, it would keep calling itself, which takes up space on the stack, and eventually the stack would overflow. That's what the term means. And it will usually just shut down gracefully at that point. But sometimes your whole machine just kind of like gets brain locked, and then you reboot. And I actually did that once about 3 years ago, and I ended up with a new laptop. I think it was coincidence, but my machine just like did not perform well after that, and I ended up getting a new one. So, yeah, so cool stuff to try.
Like even after a reboot, it didn't perform.
It had some weird problem, like some files got corrupted or something, which couldn't have been related to that, but it's like I upset the laptop deities or something. All right, so this is like perfect preamble because we're thinking deeper about well, what's going on in the system. So this is perfect setup for argc, argv, and I want to talk about something called GDB, and we'll talk about this a lot in 222. But I want to introduce it to you mainly because it's a useful way to play with these command line arguments. And I got to introduce it sometimes, so we may as well do it here. So I'm going to go back to Go because it's a nice name.
But you didn't fix the other.
Oh yeah, I'll get to it. All right, so that looks like legal code, right? So I run Go, it doesn't do anything, right? Because it just sets I equal to 5. But if I put command line arguments on here, like Go hello, right? Presumably argc was equal to 2, argv bracket 1 was Go, argv bracket 2 was hello, and then it said I equal to 5 and it exited. Okay, I want to explore what's going on inside this program when it runs. In particular, I want to examine argc and argv and see what exactly they are. So when I compile, I'm going to add a switch, which is -G. So I'm going to put that in right after GCC, GCC-G, and then I'm going to do my usual -O. Go is the name of the output file. And then the source file at the end, go.c.
Now, can you just put -GO, or do you have to do?
I think you can do -GO. All right, so I still have my executable program. It doesn't do anything, but now I can run this command GDB. And the way you do GDB is you say GDB space and the name of an executable program, hopefully one you've compiled with -G. And it brings up a new program called the Canoe Debugger. And this is a way to basically execute your program in a very controlled environment that lets you do things like, say, execute one instruction, or let me look at the value of this variable, or let me look at the address of that variable, or let me look at this location in memory. Okay, it lets you sort of examine the environment in which your program is running. And it's useful for debugging because, for example, if you're running your code and it's supposed to print out the number 5 and instead it prints the number 10, you can say, okay, go until you get to that print statement and let's look at the value you're printing. Okay, it should be 5, it's supposed to be 10. It's printing out 5. Where did this value come from? Well, it took these two numbers and added them together. Let's look at the value of those two variables and see which one is wrong. And when you figure out, there's something going wrong in this function, you can go back and rerun your program. And when it gets to that function, you can say, okay, stop, and let me look at what happens one step at a time. And it's kind of doing what you do when I say play computer, when I say pretend you're a computer interpreting this code, write down the values of your variables when they change, and so on and so forth. Well, that's what GDB will do for you, okay, except it's actually the computer doing it, so it won't make mistakes. It won't sort of be blinded by what you think the code is supposed to be doing. So we're going to do a really simple use of GDB, which is just to look at argc and argv. So I'm going to say run, well, let's see. I'm going to say list. So there's my program. So I'm going to put a breakpoint at line 5, which means once I start running, when it gets to line 5, it'll stop running and it'll come back to this prompt. And let me say something. So I'm just going to say run. And it says stopped at line 5. Okay, I'm inside a function called main. Main is a function, right? Return type, name, parentheses, list of arguments. That's how we write main. And it's actually showing me the values of argc and argv in parentheses there. But if I didn't have that, right, I could say print, P is a shortcut for print argc, and it would show me it's equal to 1. And print argv, and it's equal to this big long hex number.
Can you unhex it in GDB?
Yeah, you can change it to decimal. I think P/D maybe. Yeah.
Okay, can you dereference it?
Yes. So if I want to see what argv is pointing to, I can say P star argv, and it's pointing to this value right here. Another memory address. And I can say, let's see what's at that memory location in hex. What's at that memory location is a 2F, a 6.8, a DF, a 6D, a 6.5, a 2F, a 6E, a 6.9. When you see numbers like this that start with 6s or 7s or Bs or Cs, it's probably ASCII code. If you see 00 or FF, you're probably looking at binary stuff. But when you see particularly things that start with 6s or 7s, you're probably looking at printable characters. So I can go back to my examine instruction. I can say, let's examine this as a character. And it tells me at that memory location there's a slash, followed by an HOME. Right? And this is...
What are you doing to keep running that? Just pressing enter?
Oh yeah, when you hit enter, it repeats the last command. So at this address, FE984 is the beginning of a character array that contains this big long string. Okay, that's the name of the program that we were running, this program Go. It's actually got the full path. So it shows you where it's located and then the name of the executable Go.
But argv doesn't actually have the full path, or does it?
argv does not. So argv itself is this number here. So let's make what we can call a memory map. So here's memory, address, and contents, and meaning. Alright, so argv is actually equal to 7FFFFFFF and then E658. Okay, so that's a memory address. It's a location in my 16 gigabytes of memory on my laptop. That's what argv is equal to. Okay, it's equal to this number. What is stored in that location is when I print this star argv, it's saying show me what's at location E658, and it's another hex number which ends with E984. If I go to that location, what I find is a slash, and if I go to the next location,
So where's go? When you type argv1,
argv1 is actually going to be 0. There's only one command line argument because I didn't put any.
so argv0 is go.
Is go, right.
But then why is that full path at argv?
So argv is equal to E658, right? And the contents of that memory location is E984. That's the path. That's the first argument. That's argv bracket 0. Let's look at the next location. So argv is equal to this. Let's examine in hex this memory location. How do I make a word? Okay. So at that memory location, I find FFFFF, E984. Okay. At the next memory location is a 7FF. Those two things form a single 64-bit number. Okay, that's a 7FFF, E984. That's the value of argv, right? This thing up here. If I look at the next memory locations, it's all 0. So let me add something to this. So E660 and E664, this is 0. Okay, so what does all this mean? Char star star argv. Argv is a pointer, which means argv is an array. And argv, the name argv, is the address of the first thing in that array. Okay, argv is E658. This is the address of the first thing in the array. So what we find there is actually the first thing in the argv array. It's argv bracket 0. And it's a big long hexadecimal number. Takes up 64 bits, so 8 bytes, E658. If we go 8 bytes after that, E660, what we find there is a 0. That's what argv bracket 1 is equal to. So argv is really an array of pointers. It's an array of char star, pointers to characters. Argv bracket 0 has this value. That's a memory location. It's a pointer to a character. What do we find at that location? We find a slash. E984. And we find a slash followed by HOME slash nick slash files slash 224 slash get slash GO, and finally followed by a null terminator. So argv bracket 0 has an address in it. At that address we find the name of the program. Argv bracket 1 is equal to null. We're never supposed to use argv bracket 1. How do we know that? Because argc is equal to 1. Since argc is 1, we're only allowed to use argv bracket 0.
If we, okay, so really quickly, that just made me think: is that in the code? Like, is that how it checks?
So in the
argc is argv can only be used argc minus 1.
That's what you should do in your code, yeah. So in the ODPs, when you're trying to parse command line argument argv bracket 2, don't do that unless argc is at least equal to 3. Right? If argc, I think we were trying to parse argv bracket 1, but you're also supposed to check and make sure argc is at least 2. If it's not 2, if it's 1, you can't look at argv bracket 1. Right, so yeah, in your code, usually you look at argc, and based on that, you can start looking at different values in the argv array.
And then when you printf argv bracket 0, instead of getting the full path, you just get go.
You'd probably get the whole thing, actually. You should.
Oh.
But I'm running this inside GDB, so it might be adding the full path. All right, so let's run. Let's run this, but let's put in some more command line arguments. And it'll warn you that you're in the middle of a debugging session. Do you want to start over? You just say yes. Okay, so we've stopped here. Well, now I can see argc is equal to 5, and argv is E628, which is a different value. So if I look at argv bracket 0, that's the contents of file memory E973. That's the path to the file. Right. If I look at argv bracket 1, it's the first command line argument. If I look at argv bracket 2, it's the next, and so on. But if I actually look at this memory location, right, the thing that argv is pointing to is 7FFF E973. Okay, that's the address where this string began. The next element in the argv array is 7FFF E990. That's the address where the second string is stored. And if I look at the next two locations, the address is 7FFF E995. That's where the third string was stored. So it's an array of pointers where each pointer is pointing to an array of characters. That's the car star star part. Now the good news is we don't have to understand this for CSE 224. Okay, we're fine just saying argv bracket 0 is the first argument, it's the name of the program. Argv bracket 1 is the command you put after the program name. Argv bracket 2 is the next command, and use argc to know how many things you had on the command line. That's all we need to know about argc argv for this course. Okay, but I don't want them to be completely mysterious, right? And when we get into 222, we're going to be spending a lot of time inside GDB. And the whole game of CSE 222 is we're going to be creating what are called data structures. And data structures are basically collections of data that don't exist until the program runs. So most programs we write in C, we say integer I, we say character temp bracket 1000, we say x equals this value, right? Inside the code itself is all the stuff we're planning to do with memory. We're going to have an array. We said here's an array, right? In 222, we're going to do things like create an array while the program is running. And there's nothing in your program that you can look at and say, I'm going to have an array that holds 120 characters. But somewhere when the code is executing, it's going to, on the fly, dynamically create an array with 120 characters. Or maybe an array of pointers to strings, like argv is. And this is going to happen while it's running, not while you're writing the code, but while it's executing. And the only way we're going to be able to know what's going on is by doing this kind of thing, by using commands in GDB to examine memory. And you're going to be making pictures, memory maps that show you what's where, and let you know that, you know, this is pointing here, and so on and so forth. That's going to be the whole gig in 222. So I want to introduce GDB here and at least put it in your brains. And we'll play a little more with it this quarter to use it for debugging some C code. But ultimately, where we're going in winter, we're going to start using it to basically examine what's going on inside the machine while it's running. This is also really good from a hacking perspective, right? If you want to do something like reverse engineer a game or, you know, cheat the password in Rogue, not that I've ever done that, you know, this is a useful tool because it executes your program one instruction at a time and lets you look at things as it's executing. And you can figure out a lot, even if you don't have source code, about what's going on in your code. You can also do things like examine your program memory and interpret it as assembly language instructions. So here I'm looking at assembly language. What's libc, csu, init? It's part of the operating system, part of the runtime library. It's not code that I wrote, but it's stuff that's doing something.
So this is what we should do to your example files.
Yeah.
Yeah.
Yeah, so I mean, you could do this to assess, but
Assess is just connecting you to the server though, right?
yeah,
So,
but you can do it to the test bed, figure out what the test bed is. But I feel like I've hit a point with assess where the easiest path to getting a good grade is actually doing the work. There are other ways to do it, but it takes more work and you'll end up learning even more, so I'm kind of okay with that.
Do we get extra credit?
You will in life, I guarantee. Yeah, this is fun stuff. I mean, it's particularly if you're on your own machine and you can have root access, right? This is a great way to figure out all kinds of things, operating systems and computer architecture, and this was how I learned about computers, right? Because there was no Google, there weren't a lot of books, but everything you need to know is right there in the box. It's in the memory, and you know, it's just there for examining and playing with. So GDB is fun, and we'll play more with it, like I say, just from a debugging perspective. But eventually, we'll be using it to snoop around memory.
so if you use GDB without the
The G
without first-
switch.
yeah, without the G switch.
So if you do it with the G switch, you can do things like say list and see your source code listing. You can use variable names like I, and you lose that if you don't have the -G switch. But you can still examine memory, right? So it's harder, and this will even include comments, right? So there's an old version. Anybody remember what a Palm Pilot is? Awesome. Palm Pilot was a little handheld personal device, a PDA, that you carry around in your pocket, and you could do things that you do on your smartphone now. It was before smartphones were a thing. If you watch old episodes of 24, it's funny, they were using Palm Pilots, and they were doing things that like every smartphone does now, but it was like groundbreaking. It's like, I've got GPS coordinates, you know. There was a day when they pushed out an update of the Palm Pilot operating system, and they accidentally had compiled all of the code with a -G switch. And so everybody got this, and they just ran it through GDB and got the source code and published it. And there was good speculation that was not an accident; it was on purpose, because they wanted to have this thing opened up. But it was a way to do open source without officially doing it, so it was accidentally leaked. All right. Cool. So other questions, comments about that?
Wait, how did people figure that out? Were they like, hey, I wonder if I can debug this new version?
Heck yeah. That's what you do.
Did you not do that?
Yeah, someone was probably running it through GDB just to like see what it was doing in general, but when they got into GDB, normally it'll say, you know, no debugging symbols available. And if it doesn't say that, it's like, ooh, what's going on here? There's a lot of people out there, so the chance of someone doing something is pretty high.
That's good.
Yeah. All right. Let's play with Linux for 10 minutes. Let me tell you some more stuff about Linux. So we're sitting here in a directory. So you know, if you say ls, it shows you a list of files in the directory, right? And if you want to see the contents of a file, well, we usually just hop into VI. Let's do a bigger one. We usually just hop into VI, and that lets us see our code. VI is a little heavy-handed for examining files, though, right? It's a live editor. Once you say VI file name, you can start changing this file. And if you just want to look at a file, especially if it's not a file that you created and you have backups of and stuff, VI is a little bit dangerous, right? So you get distracted and you just start drumming your fingers on the keyboard, and you're changing your file, you know. And you try to quit, and it says, oh, add an exclamation mark, and maybe you do a :X habitually to get out of VI. Most people seem to do that. And now I've munged my file, right? And my undo won't work at this point. So if you want to just look at a file, a better way is to use cat. So cat says, show me the contents of a file. And it shows it to you, and you're done. You're back at a prompt. and there's no opportunity to accidentally change it.
And if it's a big file, you can type it through more.
Yeah, so the problem with CAT is if you have a big file, it just scrolls off the screen. And now if you want to find the beginning of it, you gotta scroll backwards, you know, or worse yet, use the scroll bar, which is always a nightmare for me. And now you're playing a little video game to like find the beginning. It's like, oh yeah, there it is. Okay. So there's a better command than cat for looking at long files. So more will show you the contents of a file one page at a time. It'll show you the first screen full, and it'll sit there. And you can look at it, and you can read it, and then if you want to go on, you can just hit a space bar, and it'll go down to the next page. If you want to go back, you can hit a B, which I did not know an hour ago, but somebody asked that last section, so we found out what it was. So you can go forward with space bar, you can go back with B. And if you hit a question mark, you can see lots of commands you can do in here. Right, so you can go forward by a few lines and so on and so forth. And if you hit an enter, it'll just go down one line at a time. You can search for things, so you can say slash and let's search for PS, and it'll bring me down to the next spot in my file where the word PS appears. So the third line there is setting my prompt. And I could hit an N to look for another occurrence of it. So there's another spot where it occurred. And there's all kinds of things you can do in here. So Q gets you out of more. Okay, Control D won't do it. Control D normally says end of file. Q gets you.
C.
Control C will also get you out. Control C is kind of heavy-handed. It's like just sort of killing things off. So Q is the nice clean way to get out. Control C gets you out of most things. There's also a command less, and most people tend to use less rather than more. I've never used less. It does different things. It's presumably better, right? The joke is less is more. So it's what a lot of people use, but I usually just use more. And when you do a manual page, the output from the man command is actually being run through less, right? And so that's why you can read this one page at a time, and so on and so forth, and hit Q to quit. And for less, you can hit an H to get help, and it'll show you all kinds of options that you can do. So it's got lots of features.
You can only do half the window height too,
Yeah.
instead of the full window.
So less and more are good ways to look at output in a more controlled way. All right, a cool command is top. Top is a nice little quick command that shows you what's going on your system. So I just say top enter, and top is another one of these weird commands you use a Q to quit instead of a Control D. So what does top tell you? Well, it shows you the time, 11:45, 50 seconds. My machine's been up for 4 days, 23 hours. There's 2 users, those are both me. Load average is sort of a relative measure of how heavily weighted your CPU is. And it's just a number, and 0 would mean nothing is going on in the CPU. If it's less than 1, your machine's pretty much idle. Less than 1 or 2, it's really not doing a lot. When it gets up to 4 or 5, there's something using the CPU, but it's not really an issue. If it gets up to like 10 or 12, you're probably noticing a slowdown. If it gets up to like 20 or 25, something probably really heavy is happening, or something has gone wrong. And it's showing us, I believe, current load average, 1 minute average, and 5 minute average. So you can see not just what the load is now, but what it's been over the past period. 283 tasks, so total of 283 processes. Only one of them is running. Guess which process is running?
Top.
Top. Because every time top runs, it looks around and says, everybody else is just sleeping. I guess I'm the only one doing anything, so it says one process is running. Sometimes 2. So 235 sleeping, that means they're probably waiting for input or some other event to occur. So most of these processes aren't really doing a whole lot. Pulse audio is the audio system. Kazam is the screen recorder running in the background. That's taking about half my CPU, right? 42%,
Cheese.
46%. Cheese is the projector, right? So that's taking about 3% of the CPU. That's what's doing that. Not the projector, the document scanner.
Does it sort by CPU?
And it
or-
sorts by CPU, I believe, yeah.
Yeah. And can you change that?
And yeah, there's a million switches you can put on top to change how it's displayed and how many lines are shown and stuff like that. But it gives you a nice kind of view of what's going on in your system. And if we run this on the Linux server, we've got some stray rogue processes running, which I need to kill this afternoon. But you can see there's 5 rogues, and they're each taking about 20%. They're splitting the CPUs, 100% availability, and then everything else, SSHD,
286 hours.
and VI is just hanging out. Yeah, so those, I haven't figured out exactly what it is, but sometimes there's ways people exit rogue that leaves it running.
What is a
So it's a
zombie?
rogue. A zombie is a process that has died but is still walking around. And it happens sometimes, you kill it, and technically it's dead, but it's still there and it's still doing stuff.
Right,
So it's a
'cause
zombie.
You need to hit it in the head.
And there's orphans, which are processes that have no parents, and they get adopted by a process called a NIT. And yeah, there's all sorts of terminology.
Have you tried looking at HTOP?
No,
It's a top, but it's slightly different. You don't have it installed.
don't have it on here. Okay,
But
I'll
it's,
play with that.
It's kind of like a nice to look at. It. Like it gives you the CPU and memory as a bar.
Oh, cool, okay.
Switches, stuff like that.
Cool. All right, so so we'll go through some more Unix commands tomorrow. Definitely bring questions on PA2, and I will see you then.
I keep forgetting.